And over the next 30 to 45 minutes, I want to take you from zero to actually understanding how to build a privacy first application on Midnight, and also writing your first line of Compact. Also, if this is your first time learning about Compact or hearing about Compact, no worries, I'm going to go over everything that you need to know. So by the time you finish this workshop and you only remember one thing, I want it to be this, which is privacy is not an add-on, it is a property of system that you build. And it is not something that is an afterthought anymore. Privacy is here to stay. So Midnight gives you the tools to make it properly yours and also to allow you build an application that is privacy preserving by default. There's a QR code I'm going to share later on for the resources, so you can get started immediately. And I'm also going to, at the end of this workshop, share my slide, so in case you find anything there and you want to make good use of it. So let's get right into it. My name is Idris. I am a developer educator at Midnight Foundation, which means my whole job is essentially to make sure people like you can pick things without losing your mind and also find everything easy peasy when you are going through our documentation, when you're trying to build on Midnight. Before Midnight, I've been a backend engineer. I've also been a developer relations engineer working across different chains, both EVMs and even non-EVM ecosystem. And I'm also the founder of a community to help onboard new builders into the space. Quick story, I just quickly want to touch on and share that I have similar background with anyone listening right now, or probably maybe some of us here, because I started my own experience, my journey as a developer, learning to code from a mobile phone. I remember clearly, it's an HTC mobile phone in the university, because I couldn't afford a laptop at the time. And then I'm telling you that's not because from the sympathy angle, but because the bar to start building meaningful things is generally lower than people think, right? If I could do it on iPhone, on a phone rather, an HTC phone at the time, you could do it whenever, or you could do it on whatever you have got in front of you right now. So, but then you can find me on socials at Assert. Please send me a message at any point in time if you are stuck or you have any question or comment or feedback. I'll be happy to answer them. So let's look at what we are covering today. In this session, we'll be talking about a couple of things. First, we'll start by looking into traditional web application, how they handle data, because that's the world where most of us are already familiar with. And then I will show you how public blockchain tried to fix some of that and where they fall short. From there, we get to talk about Midnight itself, what exactly it is, why it exists, how it actually works under the hood, and then we'll look at concrete use cases so this actually makes sense and doesn't stay abstract. And then we get into building. So I'm going to introduce you to Compact if it's your first time or you've heard about contract before. We quickly go through a couple of things around Compact. We talk about the smart contracts language. And then we look at a real contract together briefly. And from there, we keep going till the end where we get to share more resources and how you can get started. So by the end, you have enough for you to start building your project on Midnight. So let's start with the word we already know today, which are traditional web application. This is the architecture you have built in, or probably you have used. A user on the left of the screen, and a company on the right, and a stream of data packets going back and forth across the internet. So what it means is that when you sign up for any normal web service today, whether it's a bank, a shopping site, a hospital portal, you fill in a form, probably a social login or whatever it is. That means you're handing over your name, your address, your date of birth, sometimes even your medical history and financial details. And then the data gets packaged up and then sent over the internet, which then lands in the company's database. So the problem here is that once it lands there, it is there and it is there forever. And forever in most cases. The company now owns a copy of your life. That database becomes what I would call a honeypot, which is kind of a target, right? Every breach you read about in the news in the last decade in some version of this same picture, you might be familiar with this flow already because this is exactly the same flow, right? But then the most important piece is that when you send sensitive data, right, sending sensitive and private data across the internet, that's exactly the model. That's how it's currently being built, right? Sensitive data, private data, they all leave your machine and then go somewhere you can't control. It is the original scene of what web architecture looks like today. But if you ever fill out a credit card application or a credit application, or you upload your passport to verify an account, you have participated in this already. Not because anyone or everyone is evil, but that's exactly how it works today. Some of you might be thinking, okay, but blockchain, we're supposed to fix this, right? So let's see how that plays out. Traditional blockchain, right? The promise was, oh, we are going to get rid of trusted middleman or middlemen, as the case may be. Don't let company hold your data. Put it on a public ledger that nobody owns, right? Which sounds really great on paper. But in practice, public blockchain traded one problem for another. Let me show you. So here is what a typical public blockchain DApp looks like. On my screen, same user on the left, same company on the right. But now there's a blockchain in the middle where data flows through into the blocks. And a layer of metadata sits alongside that particular data that is flowing. Every transaction you make is now visible to everyone. The blocks are readable to all. The metadata, who interacted with what, when they interacted, how often is the interaction, anyone can view that. So an example is if I send you a token on Ethereum, for example, if you are familiar with Ethereum already, the whole world can see what I sent, how much I sent, and then see your address, including both the receiver and the sender addresses. They can look at your wallet history. They can correlate that with other addresses. Their entire business is built on the anonymizing public chain users. Right? But this is the part that a lot of people do not talk about, right? Where the company on the right is still capturing data outside the blockchain. The front end, the analytics, the user accounts on top of the wallet, you did not actually escape the data collection problem. You just added a permanent and public record on top of it. So let me put this into one line, right? Public chain allow correlation of public data, either public data or metadata or whatever it is on chain. So the exact keyword here is correlation. And what that means is that is doing a lot of work here. Even if a single transaction looks anonymous, right? When you have 10,000 of them, and then anyone could map a particular pattern, and that pattern becomes identity. So the score so far, if traditional web leaks your data to companies, right? Public blockchain also leaks your data to everyone. So neither of those is what most users actually want today. But then is there a third option? And that's exactly the whole point of this workshop. The solution. What would it take to get benefit of decentralization or verifiability with no single point of trust? Where we could have programmable application without giving up privacy that traditional system at least attempted to preserve. So if you have time, what exactly is this going to look like? What would be your answer today? You might have tried some privacy application or privacy chain that go all in with privacy. And that's also another problem, because that then means that auditing becomes really, really difficult. And if auditing becomes difficult, then there's no way you expect mainstream applications leveraging that type of technology. So it is quite simple. The answer here is what we call the shielded decentralized application. And that's exactly what Midnight enables. Part of the solution, which you can see right now on the screen, is it's a little bit busy, right? But if you take a clear look at it, on the left, you have a user, but now there's something attached to them, a private data that stays on their device. It never leaves the device. That is the first big shift. But then, what lives on the device itself? Of course, they are proofs. They are not sensitive data itself, but they are cryptographic proofs that says that I have the data that satisfies whatever condition that you have, or probably any condition that needs to be met. So you don't get to send your salary. You only send a proof that your salary is above some threshold, and that will fulfill or satisfy the particular condition that is required for that service. So in the middle, you have the chain, It has two layers, which is unshielded data, which is visible to everyone, but contains no metadata and shielded data. And then the other part is shielded data, which is hidden from both the public and from the company itself. And then on the last end, we have the company, which the smart contract states gets updated. The company can verify the transaction happened, but the company cannot collect the data at any point in time. But take a second to look at this again, right? The application works. The transaction settles. The user gets their service and the service they want for this particular flow. And nobody, not even the public, not the company, has had to see the underlying data. Similar to the same flow of what it looks like for traditional application, but obviously you can see where the data ends up at the end of the day. The important thing here is that data and metadata can be shielded. Private data remains with user. That's the property we couldn't get with the both models that we have before, which is the traditional web application and also the traditional blockchain. But how do we then achieve this? This is possible because zero knowledge proof, basically, right? And zero knowledge proof lets you prove a statement is true without revealing what makes it true. And that's the cryptographic primitive that makes the whole application or the whole architecture that we're talking about today possible. But then why does this matter? Why did we decide, or why do we need to have a whole blockchain around this idea? I'll tell you what that means in a moment. Why midnight? The key point here is that utility should not come at the expense of privacy and ownership. We have, as an industry, accepted trade. We said if you want the convenience of modern digital life, you have to give up control over your data. But then midnight is a bet that we actually don't actually have to accept that trade, which means that the utility and privacy can coexist together. So there are two specific reasons that I'm going to talk about in this slide. The first one is privacy is human rights in the digital era. This is in my opinion, right? The United Union, the EU went through GDPR, multiple constitutional framework, all ensuring some version of this, where the problem is that digital tools we have been building have systematically eroded this particular flow. So think about how many times this week that you have handed your personal data without really consenting. Every cookie banner, every form, every loyalty card, the defaults are stacked against you by default. So now, when you build that same kind of application on midnight, you are not just bottling on privacy after the fact. You are picking a substrate where privacy is the default, which leads me to my second point. You reclaim freedom of association, commerce, and expression. These three sounds really, really abstract. So let me make them straightforward. So what do I mean by freedom of association? Being able to belong to a group that support a particular cause, right? And or probably donate to an organization without that membership becoming a permanent public record. That's just to give you an example. It's way more beyond that. But when I mention freedom of commerce, what do I mean? In today's world, you want to be able to transact without every party in the chain or the particular ecosystem you are on know what you brought in, when you brought it in, and for how much you're doing it. If you are very familiar with how the DeFi ecosystem works or lending or stuff like that, this is very, very important piece. And then finally, which is the freedom of expression, being able to publish, post, or speak online without your identity being correlated across every platform that you have ever touched. So if you want to tie all of these things back, all three of these are tougher to exercise online today than they were probably they were generations ago, right? So midnight is the infrastructure that lets us push them back into what is accessible today. But yeah, okay, that's enough, manifesto. Let's see what people actually build or people are currently building with this. So there are several use cases, right? I cannot categorize them in 4 different categories, but of course there are a lot more potential. And nowadays we'll be even seeing AI category, AI agents. So there are a lot more, right? Just to categorize them briefly where you can easily understand it, right? We have the identity category, which is the identity use case. We have the finance, a very important piece. We have the healthcare, And then we have the gaming ecosystem. Of course, identity, proving your age without revealing date of birth, your name, your country, or wherever you're from. And then you generate a proof from your credentials. Whatever needs to verify it, maybe a gate or a system that needs to verify it, verifies it, and then you just walk in straight up. Then the verifier lean on one bit. Is it correct? Yes or no, and nothing else. And then for the finance part, there are a lot of use cases that you could find out there. Credit scoring is a classic one that everyone talks about, right? A lender wants to know if you are a good risk, or probably today that means you're handing over your entire transaction history in a way that if I want to know that you have a good score or a good credit score, so that when I give you access to a particular loan, you are able to pay me back within the period of time. With Midnight now, you can prove a credit score sit above a particular threshold without revealing the underlying transaction that produced that particular credit score or that particular threshold itself. We also have the healthcare. We've been seeing a lot of leaning on privacy and how much important privacy means for the healthcare industry. Things like clinical trial eligibility, things like prescription verification, claims, and all of that, right? All of these use cases where the data has to be exchanged today, but only a small fraction of it is actually needed. So Midnight gives you access to let you share a conclusion, not the actual file or the actual data itself. And finally, to the gaming ecosystem, where a lot of people are interested in this ecosystem a whole lot, right? Anywhere there is hidden information in the game, a hands of card, maybe a chess or battleship board or whatever it is, you can commit to your private state on-chain without revealing that particular thing. And then you can prove your move are validated against it, which makes it verifiable but completely hidden. So there are a lot of things that you could get out of building on Midnight and different use cases across board. These are just like high-level examples to paint a picture of what it looks like building a decentralized application on Midnight. Before I proceed to how Midnight actually works, because I've talked about the use case a whole lot, I'm going to pause a bit to see if there are any questions. Otherwise, I will continue. So I don't think we have any questions right now. So I'll just go ahead. Now let's talk about how Midnight works, basically, because I wouldn't mention like use case, how it is different from traditional system, what is required, and all of these things without talking about how does even Midnight works under the hood, right? On the left pane, where we have the developer system, here. Of course, that's your laptop as a developer. You write two things. Maybe you write your TypeScript app for the application and the compact contract code for the smart contract, and then the compact compiler turns the contract itself into something that can run on chain and generate ZK proof. And then in the middle where we have the web browser itself, that is the user's browser, right? The dApp runs there alongside Midnight. Let's say any extension. We have the Lace, we have the 1 AM extension. It holds user key, they can sign transaction and manage identity directly. The dApp and the wallet talk to each other locally. And then on the client side, which is my right-hand side here, that is where you have the Midnight client service, where there's a PubSub blockchain indexer, and that's how the dApp learns specifically about the new state on-chain, and if there's any non-voting mode, which gives the dApp a live view of what the chain is currently doing. And on the top right, where we have like the network, which is the Midnight network, it's directly connected to the system. And that's on its own, it's a fault tolerant network of validators that actually produce blocks itself. And then on the bottom here, you can see that we have proof server. This is very critical, to be honest. And also, it's very easy for you to miss it, right? So when generating a zero knowledge proof, and because generating a zero knowledge proof itself is computationally expensive, right? So the proof server does that work for you. It runs completely locally on a laptop or probably a desktop or a server or anywhere. Crucially, like it never sees your wallet, your seal, or your signing keys. But I'm going to come back to proof server in a moment. But combining all of these together, this is how they kind of plug in to have a system I've been talking about, which is a dApp that has been built on Midnight and how people or users can interact with it. But then with all of these parts that I've mentioned, what do you actually need to spin up to start building? There are a few things here if you want to build as a developer. A 3 core endpoint that you need to talk to as a developer. The first one is the node, which is where your transaction lands in, right? When your dApp wants to submit a transaction, this is the door. If you are not running locally and you want to hit the Midnight, maybe public preprod, you can point at this RPC. But if it's a node locally, then this is what the endpoint looks like. And then the second part, which is the indexer, you can see the endpoint here. This is where all things like reads, query the contrast states, balances, all of those things, query basically happens. And then you have access to all this information right out of the box. But there's a missing piece here. I mentioned it's 3 blocks, right? 3 things. These are just 2. The last one here is the proof server. Mind you, I mentioned briefly that this is where every ZK proofs is generated, right? So every transaction needs one. That's how the chain itself verifies your action without seeing your data. The important thing to note here is that proof server never receive your wallet key or your signing key at any point in time. All of those things stays in your wallet. But the proof server only say what needs to construct the cryptographic proof. And then finally, you can see this last point I added here, which is not part of the key blocks on what you need to do, but a very good thing to showcase that the fastest way to spin up a fully local stack today is by utilizing this Midnight local dev. If you can Google it, it's in Midnight local dev, you see a repo. And what that does for you is that it helps you can spin up, clone the project, start it locally, turn on your Docker, get your proof server up and running. And you can be able to build your application locally without having to rely on prepod, network or faucets online. All you just need to do is to run npm start and you get started. Then you can connect your dApp that you're building locally to this particular Midnight local network. I would recommend you do this because number 1 is very fast. Number 2, you don't have to wait for any faucet anywhere. Number 3, it's very, very, very easy to set up when you want to get started with. So you don't have any bottleneck of getting started right away. In fact, you can do that immediately after this call. But what does building on Midnight looks like? Up to this point, we've really talked about like the concept, why privacy matters, what the architecture looks like, and the service where it runs, right? But there's something that powers this and something that makes it make sense, which is the flow from idea to deploying your code. And that brings me to compact programming language. There are 3 building blocks when you think about compact, and what are some of the things associated with it? The first part is public and private interoperability, where users should be able to express private and public computation and easily match out data across public and private boundary and to ensure its integrity via ZK circuit. This is one of the principles of why compact exists. The second one is safety. Privacy is very hard. The number of subtle ways to leak information by accident is genuinely difficult to keep in your head. So compact has a tooling a tooling that is already baked in rather, to help you reason all of these things out of the box. So one concrete example is if you try to use a private witness value in a conditional statement without explicitly marking it as disclosed, right? The compiler will refuse it. And this basically forces you to acknowledge that, yes, I know the comparison is going to leak one bit of the information about the private value. That's the kind of guardrail you want when you are building a privacy software, because the cost of getting it wrong is very, very real. And then the last principle here is familiarity. And this is very important because most developers already know TypeScript or JavaScript or familiar with it at some point. So compact was designed to feel a little bit like TypeScript adjacent. Things like the curly braces, the semicolon, the type annotation, the generics. So if you can read TypeScript, you should be able to read compact language. Obviously, TypeScript do not have ZK circuits and all of those things, right? Those are the differences that you would notice. But if you are familiar with it, you would find it quite easy, right? The honest truth is that it's not literally TypeScript, but there are some differences. Obviously, there are some differences because of the ZK constraints. The enum variable uses dot annotation, not double colon like you would see elsewhere. The circle return types uses empty tuple instead of void. So there are a couple of things that you might notice out of the box if you're already really, really good with TypeScript of building things with strictly typed language, right? Let's look at one. Let's look at how it looks like. The compat contract, for example. Basically, I've talked about this before now. A compat is strongly typed language, right? Bounded smart contract language designed to be used in combination with TypeScript for writing smart contracts for the three parts structure of Midnight. So, what are the fundamentals that you need to be aware of? A couple of things are like the pillar that you should be aware of, and they are critical. The first is ledger. You often see ledger type on smart contract on your compat contract. This is how you declare an on-chain state, right? Anything you want to write as export ledger or something lives on the chain. So it's public, it's durable, it's visible. Things also like counters, owners' addresses, public membership sets, all of those, that is your ledger. Then the second piece here, which is a witness, a foreign function interface to TypeScript used to define an off-chain program. This is the door to your off-chain component, which is the TypeScript, where a witness function, a witness is like when you use a witness, you declare it in compat, but it is implemented in TypeScript on the user's machine. So when you need to access private data, things like the user secret, a value they are keeping local, a piece of off-chain state, you declare a witness in your contract, and then the prover provides the value when generating the proof. So it's better to know that witnesses are declaration only. You don't put a body on them in compat. The body lives in TypeScript, and everything happens locally. And then finally, which is the assert, where information needs to be verified before circuit can proceed. Right. Think of it like a conditional statement to ascertain something before implementation can go ahead. It could be validation. You can call it validation if you're familiar with a web application. You can call it like a verification layer or something of sort before the code continue running. And then we have two more concepts, which is the circuit and then the disclose. You often see circuit in compat code. This is the unit of computation in compat, basically. So a circuit is a function that compiles into zero-knowledge proof circuit. It can read your private state witness data. It does computation over it and optionally updates the ledger state. And then at the end of the day, produce a proof that everything has happened correctly. So you often see this keyword when you are writing your compat programs. And then finally, the disclose. This is the safety mechanism I mentioned earlier on. So if you have a private witness value and you want to do something with it, that will review the information, store it on chain, or like compare it in a condition and return it. If you want to do all of those things, you need to wrap it in something called disclose. That is you, the developer, explicitly acknowledging that, yes, I know this is going from private encrypted data to public, right? But the compiler will refuse to compile if you don't have the disclose specified. So it's a very important piece of function or piece of safety mechanism that allow you to do things correctly and make you aware of what you are doing when you are doing it. So putting all of this together, ledger is your public state, witness is your private off-chain channel, circuit is the computation that ties them together, and then assert enforces your rules and disclose explicitly mark the public and private state boundaries when you are building your application. So that's the entire mental model. But when you look at the primitive, there are a couple of primitives which you might already be familiar with, like the Boolean, the integer, depending on your integer, the fields, the vector, the byte, the opaque. All of these things have independent and different actions. And then when you need to use them, all you have to do is just specify them within your contract. So what do you need to get started if you want to get started right now? I would encourage anyone right now to scan this QR code. It takes you directly to what you need to get started at this point. If you have not started anything, this is the best place to get started today. So even if you have never touched Midnight before, this is your entry point. It walks you through installing your tool chain, scaffolding your first project, deploying an hello world contract and all of those things, right? And you see everything in action. Scan it now, even if you don't need it tonight. You should bookmark it because you will obviously need it at some point. So let me share a couple of resources that you would find useful, because this is, instead of you trying to figure out where you can find everything, right? We have the Developer Hub, And this is a one-stop shop for our dev resources. If you click on it, like if you go to the website, Developer Hub, Midnight Developer Hub, or midnight.network, and then you go to the Developer Hub, you'll see a lot of resources already like listed over there. And then getting started, also a quick start on compact programming language. I'm going to share this this deck so you can have access to the links directly. Preferably, you can also Google them directly and you'll find it. We have the Awesome App repo, which is a collection of repos on the Midnight network. And this is often contributions from builders outside the ecosystem, and anyone that built something in the past and wants to get it listed, please go ahead and send in a PR. If you Google Midnight Awesome App repo, you will see the GitHub repository. And then we have the Midnight YouTube channel, where we do have lives. We do have Fireside Hang every Wednesday happening on YouTube. We have recorded explainer videos on our YouTube. We have technical videos. We have how-to videos. We have a lot more videos also coming up soon to teach you what you need to learn at every point in time. Additional resources include Midnight Academy. If you're hearing Midnight for the first time, just Google Midnight Academy. It will take you to academy.midnight.network. If you have never heard about compact before, privacy, it doesn't make sense to you at all, check out Midnight Academy today. And that will take you from 0 to 1 on what you need to get started. We also have the Zilly Quest, which is a way for us to have a gamified experience for you to learn. As you learn, you complete a particular task, you get rewarded for the task. We have the Elite, which is support from our Midnight Fellows. You can also apply to become an Elite member. We have the Build Club, which is an 8 weeks program designed to help builders go from 0 to 1, from the ideation stage to the planning stage to execution to acquiring your customer, and also learning about marketing and all of that. We have that program. And then we have a community board where we do share content, we do share DApp ideas. Right now, we have a bounty, ongoing bounty. It was posted there where you can contribute to content and get paid for your contribution. And then we have the Midnight Forum where you can get help with the code on the forum or on our Discord channel. You can scan this QR code. It takes you to a very detailed PDF that has all the links to everything I've been talking about today. And then that's it. Thank you so much for listening. Thank you for, I'm genuinely grateful for you all coming to this workshop. It means you really need this and you are intentional about it. So I appreciate you spending some time here. So I have 2 asks. One is if you are building anything on Midnight during this hackathon, even if it's half finished product, make sure you share with the public, make sure you share with us. We'll be happy to give feedback. The other part, if you get stuck at any point in time, please don't suffer in silence. You can go direct to our Discord server, dev chats, or the hackers chats there. Ask questions, we'll be happy to help you. You can also find me on social media at Olanesoft. Probably you're having issues, you can DM me, I'll be happy to help you. Have a brilliant hackathon. Now go ahead and build something quite important. This is the final QR code. It's a 1-minute survey. Tell me what you think about this presentation. How has this been able to help you get started with the hackathon? And if you have any questions right now, we're happy to answer all. Thank you for your time.
Yeah, that was a great workshop, Idris. It's really nice to see all the resources Midnight has available to early stage developers.